In this video, I will continue talking about function machines. The video will cover F6 and F7. In F6, we will be solving equations using function machines. Let's look at the first one. Here, our equation is 3x plus 5 equals 17. We will be trying to find the value of the variable x. And we can do that by using a function machine. So let's do the function machine together. We start with x. Remember, 3x means 3 lots of x, so the first function is multiplying by 3. And then we move on. And the second function is adding 5 to this result. So we add 5. And then the final answer is 17. This is the output of our function machine. Now we are not finished because we are trying to find the value of x. This is what we mean by solving the equation, finding the value of variable x. To find that, we can work backwards from 17 using our inverse operations. So we start at 17 and work backwards. The inverse operation of adding 5 is taking away 5. Our intermediate result is 12. And then the inverse of multiplying by 3 is dividing by 3, which means our final answer will be 12 divided by 3, 4. The value of x is 4. Pause the video now and try to work out what is the value of y in the second example. Here we need to remember the order of the operations. Remember that the order of operations goes as such. At the top level we have brackets, and then we have indices, and then multiplication and division, and addition and subtraction. That means that we will do multiplication before we do addition, because multiplication takes priority over addition. So if we look at our equation, 8 plus 4y equals 36. And we do it the same way as we did in the previous example. We're trying to find the value of y. So y will be our input into our function machine, because this is our variable. So we're trying to find what is the first operation we did to the variable y. Is it adding 8 or is it multiplying by 4? Remember that according to the order of operations, multiplication comes before addition. Therefore, we did multiplying by 4 before we did adding 8. So the first function is multiply by 4. The result of this will be 4y. We then take that and add 8 to it. After this, the output of the function machine is the right-hand side of our equation, which is 36. And as we did before, we can work backwards to find the value of the variable y. Starting from 36, the inverse operation of plus 8 is take away 8, which will give us 28. And then the inverse operation of multiplying by 4 is dividing by 4. 28 divided by 4 is 7, therefore y equals 7. And now it's your turn. Pause the video here and have a go at these two questions. Use what we just learned about order of operations, and don't forget that multiplication comes before addition. This will be our function machine, and if we're trying to work out the value of variable x, we can start from 21 and work backwards using our inverses. Our intermediate result is 30, and the final answer is x equals 15. For the second one, we can do it how we did it before. Remember your order of operations. This will be our function machine, and again we are trying to find the value of variable y. We can start going backwards using our inverse operations. And you can see the steps outlined there. Y equals 3. We'll now move on to equations which involve fractions as algebraic expressions. Let's look at the first one. Here, we are trying to solve x divided by 5, take away 7, equals 4. Again, we'll start with x, which is our variable, and this will be the input to our function machine. So let's now draw our function machine. The first function we did is dividing by 5. That gave us the intermediate result of x over 5. We then subtracted 7 from this, and the final output of the function machine is 4. Again, as we did before, we are trying to find the value of variable x, so we can work backwards from 4 using the inverse operations of these two operations. 4 add 7 will be 11, multiplied by 5 is 55. Therefore x equals 55. Pause here and try to work out the second one for yourself. Well done if you remembered to use the order of operations to solve this question. We start with the variable y. This will be our input, y, and then very important that the first function in our function machine will be division by 4, as this operation comes before addition in the order of operations. We then move on to adding 5, and the output of our function machine will be 11. As we did before, we can work backwards to find y, starting from 11, using our inverse operations. 11 take away 5 will be 6. 6 multiplied by 4 will be 24. Therefore y equals 24. Now you can test if you understood. Pause the video here and have a go at these two questions yourself. The first question is to solve x over 3, take away 9 equals 12. The input will be x, and the output will be 12. We then work backwards to find x. Using the inverse operations of the two operations in the function machine, and the value of variable x will be 63. The next question is very similar to the question we did before. We start with y. We draw our function machine like this, and then we work out the value of y by going backwards 120. Using the inverse operations, we'll find that the final answer is 5 multiplied by 7, which is 35. Therefore, the value of variable y is 35. We'll now look at a worded problem where we can apply the knowledge we just learned in the previous topics. In this worded problem, I think of a number, I add 4, then double it, and the answer is 30. The question is, what was my original number? When we are presented with questions like this, we can name our original number as x, so that it's easier to handle. X will be this variable which we are trying to find. We can represent this whole question on a function machine. Let's follow the text. We started with x, we added 4 to it, and then we doubled it. Doubling means multiplying by 2. So we have multiplied the result of the first function by 2, and the final output will be 30. So to work out what was the original number, x, we can start from 30 and use inverse operations to go backwards. The inverse of multiplying by 2 is dividing by 2. 30 divided by 2 is 15. This will be my intermediate answer. And then next, the inverse of adding 4 is subtracting 4. 15 take away 4 is 11. Therefore, my original number, x, will be 11. We can give a full answer, and we can say, my original number was 11. So now you know how to solve function machine questions.